You'll notice when you do these problems, the same kind of thing happens over and over and over. The same kind of tricks, the same kind of rules, the same kind of problems. So what's going to happen next is something that we've done already today. Let me do a little bit of side work for your viewing pleasure. Pythagorean identity number 1. Sine squared of x plus cosine squared of x equals 1. If you get cosine squared by itself, cosine squared is equal to 1 minus sine squared of x. Do you all see that? Is which over 1? So the top just becomes cosine squared of x. Do you all see it? Not x, I'm sorry. Phi. This is an autopilot moment right now. Right, our numerator has cosine squared. Our denominator has a cosine, so they cancel. So on the left, we're left with cosine of phi over sine of phi. Keep looking back to the right. We're trying to get cotangent. This equals cotangent. Finished. When you start doing well at this, and you will start doing well at this, you're going to have such a great sense of accomplishment. All right, number 5. I want you to go nuts on number 5 right now. Go nuts on it. Do it. No, don't be a coward. I know, that's why I said don't be one. I know you're a coward. If you weren't a coward, I wouldn't say don't be one. Yeah. If you follow the advice, the most important one that I think that I've said the last 3 days, if today counts as the day, change everything to sine and cosine when you have doubts. Great things happen. Great things happen. Secant is a reciprocal of cosine. Cotangent is a quotient identity. Everything cancels except for a 1. 1 equals 1. Number 6. Secant squared of y minus tangent squared of y equals tangent of y cotangent of y. Here's what I would do for this one. I would change secant squared of y to tangent squared of y plus 1. Do y'all see that identity? It's one of the Pythagorean identities. Then on the left, your tangent squared of y's cancel. So the left side is just 1. What happens on the right side when you multiply a trig function times its reciprocal? You get 1. Anytime you multiply anything times the reciprocal, you get 1. So 1 equals 1. Anything is easy if you know the solution. Right? All right, example B. Ladies and gentlemen, example B is different. It says find a numerical value, that means a number, of one trig function. That means you can only have one trig function of each x. There are potentially 12 different correct answers for each of these. You just need one. You just need one of the 12. Sometimes there's 6 right answers, sometimes there's 12. I believe on the homework I have all possible answers. You just need one for these. So you're finished when you have one trig function equal to a number. That's when you're finished. I would change tangent of x to sine over cosine. I don't always do that, but I do that very often. Trying to get just to be one trig function. I'm going to multiply both sides by cosine. The work for these problems, like the other ones, can look very different from someone else's work, and both people can have the correct answer. Then if I divide both sides by sine, then I get cosine by itself. That equals 1. So one answer for this is cosine of x is 1. You only need one. Had someone else done this different, they could have an answer for sine of x equals something, or tangent, or cosecant, or secant, or cotangent. No. Number 2. You see that number 2 by number 2? That big turd, number 2? Let's get the 2 by itself. Then we'll have that part done. To do so, you're going to divide both sides by tangent. So the right side's not finished because there's 2 different trig functions. We need it to just be one trig function. So what you could do, you could change your denominator to its reciprocal, which is 1 over cotangent of x. Tangent reciprocal is cotangent. This is an autopilot moment. You have a complex fraction. Your numerator divided by a fraction is like your numerator times the reciprocal of your denominator. Cotangent of x times cotangent of x divided by 1 is going to be cotangent squared of x. It's not it because it has to just be the trig function by itself. There's a squared there. You square root both sides, and you get plus or minus the square root of 2 equals cotangent of x. That's actually 2 different answers. One answer is the positive square root of 2 equals cotangent of x. Another is the negative. So for this problem, there's 12 different answers because of the pluses or minuses. You only need one of the 12. Number 3 is nice because the right side already has a number by itself, 9/16. The left side, anybody have a suggestion? change secant to 1 over cosine, you get this. Leave the bottom the same or change it to? What would you like to change it to? If you don't know what to do, do something. And a lot of times that something is change everything to terms of sine and cosine. I'll give you an F. This is an autopilot moment. Our numerator is sine times 1 over cosine. That's just going to be sine over cosine. And instead of dividing by this fraction, why don't we instead multiply by its reciprocal? I believe we're still in autopilot here. You're multiplying two fractions. You multiply the tops together. Something times itself is squared. Multiply the bottoms together. Now thinking comes in because it's pretty simple on the left. Can you use a trig identity to make it hopefully into one trig function instead of having two different trig functions? Yes, sir. Right. It becomes tangent squared of x. And the right side this whole time has been 9/16. We're not finished because it's supposed to be just tangent, not tangent squared. You square root both sides. When you square root a fraction, you square root the top and the bottom. This is a perfect square, so you're going to get plus or minus 3/4, which is actually two separate answers. We only need one. This one has 12 different answers. I can't count it wrong because you only need one answer, although I'll be cursing internally.